And we are live. If anybody wants to share the streaming link, there is an option to copy streaming link if you go to the top level controls. I just tweeted about it. And I will open the streaming link here so I can see the chat window in there as well. And there's obviously up to 20 seconds lag between the two. We will start in 1 or 2 minutes. So grab that drink if you haven't done so. Don't be dehydrated. I pasted the streaming link in the chat window if anybody wants to use. OSS 2020 is the hashtag. All right, let's kick off. Hello, everybody. I'm seeing lots of familiar names now. This is the second week of the training weeks at the summit. Welcome back. If you are new, thanks for joining us. As I said, this is Open Security Summit Training Week, week 2, day 2 in week 2. And we are joined by Sasha, and we're going to be doing a 2-part training session on GitHub Actions, firstly, and then CodeQL code scanning. A bit about the Open Security Summit. The summit is a community. It's not just one event, but we have a Slack community group where I will share the link for invite in a second. So this is a very collaborative group of people. We mainly talk about security, but we're not all from a security background. So we are here to learn from each other and take the security industry and security standards to a next level. So everything we do at the summit becomes like a Creative Commons, something to build up on and to use. So we try to be as practical as possible. So normally these happen in a room in a forest, but this year with COVID, we had the opportunity to make it virtual, and by that way, to reach multiple geographies as well. So we do expect your participation during the session. If you have a question, you can unmute and ask, or you can use the chat. I will be monitoring chat both in the Zoom chat session and in the YouTube, and I will be voicing the questions when the time is right. We respect you, and this is a community, and we're all here for each other. So mutual respect is key. Everyone here is spending their time, and especially our speakers, they spend more time to prepare all the things for you. So you can ask questions. Nobody knows everything, and there is no stupid questions, so don't be afraid. I do encourage you to ask your questions, because by the way, we bring more value to everyone. Openness is one key value. So everything here is shared. We are live on YouTube right now, so it is already being shared, but everything we create during the session is also shared afterwards in the website. And that is it from me. Sasha, over to you.
All right, let me see if I can share my screen. Okay. So just do let me know if you can hear me, if you can see me.
I can hear you well.
All right. So let's kick this off. This session is 2 hours long, and it's going to have 2 parts. So the first hour, we're going to talk mostly about GitHub Actions. And the second part, we're going to talk about code scanning with CodeQL for security purposes. The first part, you only need your GitHub account and a browser to follow the couple of exercises that we're going to do. The second part is a little bit more involved and requires you to install a few things on your local machine. Let's just get started with this. So I'm going to start with a quick introduction. I'm Sasha Rosenbaum. I'm originally from Ukraine, then I lived in Israel for a decade, and now I'm in the United States for almost a decade. And I started my career as a developer. Then I kind of got into ops and DevOps and automating infrastructure as code and things like that. And the last few years I spent in architecture and product management. So I kind of moved from jobs where you write code mostly to where you mostly talk to people. So that's kind of interesting and I think pretty usual career progression, I guess. I used to work for Microsoft a couple months ago. I transferred over to GitHub. You can find me on Twitter, and you can find me also on GitHub by the same name at DivineOps. So if you go to GitHub and search for my repos, there's going to be a couple of repos that we're going to use today. So that's a little bit about me. The picture is from DevOps Day Chicago. I really love DevOps Days conferences. I've been involved in DevOps Day Chicago for a long time. And once we can all travel, maybe you should all come visit and check out the conference. So I'm just going to share a link. Like I said, for the first part on actions, you only need a GitHub account and a browser, and it should all work for you. For the second part, you need VS Code and a couple of things installed in VS Code. So if you want to kind of start in the background now, you can follow this link. Notice it's a short link. So it's a github.co, not .com, and then the CodeQL JS workshop. I hope I don't lose you to installing things. So hopefully it still works okay. But yeah, go check this out. So we're going to start the first part with automating your workflows with actions. So what is GitHub Actions? I'm not sure if everyone is familiar by now, and maybe most people are, but maybe there's still some folks who haven't heard about it. GitHub Actions is something that allows you to automate different workflows with GitHub. And so we can build CI/CD, so continuous integration, continuous delivery with actions. We don't have to be limited to that. We can trigger different automated workflows, kind of anything that you need to automate with actions as well. And it's fully integrated with GitHub. You can respond to any GitHub event. It's community powered, so you can, the actions are essentially open source, and you can contribute the actions you've written to a community to the marketplace and share them with the community. And you can write them in, automate any platform, any language, and any cloud. So we're kind of open to everyone. And then this got a little bit into features, but we're going to talk a lot more about this. So we can have matrix builds, which we're going to cover, and then we can have searchable logs for these builds, and build in secret store and easily share the actions. So the great news here is that actions are free for public repos. So if you have public repos, open source projects, you can run them for free, which means that you would be running them on GitHub hosted runners. So this is something that GitHub essentially is sharing the compute power that we have with you, and you can essentially run your actions, run your builds, and any other automated workflows for free. And we also have GitHub sponsors now, so you can potentially share your actions with the community, and you can sponsor people whose actions you use, or you could also, people can also sponsor you if you're sharing your the things that you've implemented. So GitHub Actions essentially is a set of reusable components. So you kind of implement the action, and then you can share it in the marketplace, or you can keep it to yourself if you like. And then you can, fork the actions and do things like that. Now, actions essentially, there are two ways primarily right now to implement them. One is in JavaScript and the other is on Docker. So if you run in Docker containers, you can use any languages that you like. If you run in JavaScript, we kind of have a more extensible platform, but it's only one language, right? So if you implement your actions in JavaScript, you can use them on any OS. So leverage any type of platform that you want, but you're limited to one language. So this is kind of your trade-off. Honestly, if I were you and I were working on implementing an action, I would probably choose JavaScript right now. But again, if you really need a different language, you can use it on Docker containers and implement it in any language that you like. The Docker containers run only on Ubuntu, so then you're limited to a single OS on there. Now, what we're going to spend a little more time in this session in particular is going to be workflows. So what is workflows? Workflows are the pieces that kind of glue the actions together and that allow you to automate different tasks. So what happens is you or somebody else is implementing an action, and that action can be, for instance, I don't know, build a node repository, right? So all of my examples today are going to be in JavaScript, so kind of get used to that. But we also obviously can automate this for any language and any repository. This is just kind of to keep consistency for the session. So basically, the workflows start on triggers, and then they run actions in different shell scripts, and then they kind of tie it all together and allow you to implement different workflows. So basically, you can, so how do I say this in a good way? If you are just getting started, probably what you're gonna do is not implement a new action, but rather start using workflows and start using actions that were implemented by someone else already, right? Because that is kind of the useful part of this for most repositories, to implement CI/CD and other things like that. And the workflows run on virtual machines. These virtual machines can be GitHub hosted runners, and they can also be self-hosted runners. So if it's GitHub hosted runners, we have Linux, Windows, and Mac OS machines available. You can also run on Docker containers on Linux. But so this is really cool if you want to build and test your software on different platforms, because a lot of people, when they start deploying software and they need to test it, for instance, on Mac OS and on Windows and on Linux, make sure it works everywhere. They would have to buy different machines, different build servers, and just kind of start, bringing all this hardware. So we allow you to do that very, very easily without buying your own hardware. Now, if you had something, we obviously have like a set of different machines with different operating systems, but if you have something very specific that you want to run on, you can create your own VM and you can run a self-hosted runner on that. So you can run actions on any VM if you had, I don't know, a mainframe, if you really wanted to do that. So things that comprise a workflow is every workflow starts with an event trigger. So you can, for instance, trigger something on push to a repo or on other different types of events. And then you can run jobs. So jobs are components that each job runs on a single VM. So a job defines which type of VM you want to run on. In jobs by default run in parallel, you can configure them to run sequentially. And then steps are parts of the job that implement the particular workflow that you're running with. And the steps run in sequentially, not parallel. So you have the ability to run in parallel on different things to save yourself time, or run sequentially when you need to implement actions one after another. And then we have searchable logs. You can stream these logs outside. And also you can save artifacts between the runs as well. So let's just do a demo and an exercise. So if you don't want to do the exercise, you can follow me. And if you do want to do the exercise, then please right now just go to the two links that I'm sharing. So the first one is the template repo. So we're going to be working with that. And it's at github.com DivineOps Calculator. And then the second one has the demo code. So if you ever get lost, there's the actions that we're going to be implementing as we show this. So I'll give you just 1 second to potentially go to these links. And all right, I'm going to assume that most of you have had a chance. And Didar, if you want to actually let me paste this, I'm just going to do this.
Okay, thank you.
In the chat. Sorry.
I think I pasted the first one, but the second one will be good to have.
Damn. Doesn't want to go back into the meeting. Damn you, Zoom. All right, let's do this. And then this one as well. All right. Okay. So let me just go in there right now. So this is the calculator repo that we're talking about. And what it is just a simple Node.js application that implements a calculator. There's nothing special about it. We've been using it for demos because it works and because it has tests implemented. So this is just kind of an easy way to get started with something that already works. So what we're going to do is, this is a template repo. So we're going to click on use this template. And then we're going to give it a name. So choose any type of name that you want. I'm just going to use a random name. I'm going to keep it public, and I'm going to do create repository from template. So create repository from template is kind of like fork, but it severs the connection with the original repo. So when you create it from template, you lose all the history and the connection, and you can kind of do whatever you want with that repo. All right. So we have this here. I'm keeping my browser intentionally super zoomed in, so it's a little bit hard to see. But again, we just got this repository. So let's see what we can do with actions. So you can go to the Actions tab, and you will see that it by default immediately offers you certain workflows. So we know that this repo actually implements a Node.js application. So we can say, okay, we think that a couple of workflows would be immediately useful to you. So, and again, you can see that there's a bunch more here, but we're just going to start with Node.js CI, right? Because that seems useful. Most projects want to run continuous integration so they can run and build and test their code, test that it works, right? And this is, by the way, something that we see on like the most used action probably right now is CI for different languages on different projects. So we've got this already for us, right? And we can see that there's a bunch of code already in here. So let's talk about what is already in here and then make a couple of changes. Now, if you wanted to, you can just commit it right now and it will work for you. But you can also follow me and see what I'm doing. So one of the things that I want to say is that we can add different branches. So I can say I wanted to run not just on master, but also on release. And I can also specify that anything that has a path that looks like release star, pick it up, right? And then, so in this case, it runs on 2 different triggers. It runs on push to branches that are specified in here, and then it runs on pull requests. So that's the 2 ways we can start this workload. Then it defines a job, and the job is called build, and it specifies which machine it wants to run on. So this is Ubuntu latest. I'm actually going to change that so we can demonstrate what a matrix build is. So I'm going to start typing in here. I'm going to say OS, okay? And then I'm going to say actually Ubuntu. Typing is very hard. Okay, so I'm gonna say, I know that this version exists. Obviously, I need to check that this version exists in GitHub hosted runners. And then I'm gonna also type Mac OS latest. And you have to type the exact name of this machine. So kind of be careful with your syntax. Also, for added benefit, this is YAML. So if you ever miss like a space, that it won't work. So we just specified that we have 3 different OSs here. So we actually need to change this to run on that matrix. So we're going to say matrix.os, and then here also. Do we need a
between macOS and Windows latest?
Sorry, say that again.
Do we need
yes, we do. All right, absolutely. Thank you. See, type in is very hard. So, okay. So we can see now that it has a matrix of 2 things, right? It has a matrix of OS, and I'm specifying 3 different machines to run on. And it also has a matrix of node versions. So I'm running on 10, 12, and 14. Okay. And then what are the steps to this? So essentially, the first thing I'm doing is just, set up the run. And then I am running with the node versions that I specified. And then I'm doing the 3 steps, npm CI, which is going to just bring out all of my packages that I'm using here. And then I'm going to do npm build if present, and then npm test, which is essentially, this is kind of the bulk. Like, I really wanted to run the tests, and I really don't want to have a Mac OS under my desk or Windows or whatever I want to test it on. So we really want to run this command. So let's just do start command.
Questions before we move on.
Go ahead. Go ahead, please.
Someone say they're familiar with cross-platform app development. What are the cases where to use it, and what type of app you mean about the workflow thingy?
So I don't know what the second question means, but the first question, again, if you wanted to make sure that your application ran across platforms, and in some cases people have the use cases where they need to make sure that this runs on any machine, then this would be a good use case for Matrix across OS. And then if you have essentially just different node versions that you're testing with, that's another, and again, this is Node, or it can be, Java versions or whatever, but you can test for different versions as well. So basically, whatever you need to support. If you were doing like mobile development and you needed to make sure that it works on all different phones, you can do this on here, right? Because it offers you the ability to test on different OS systems.
And very related to what you just said, in the matrix, can you choose between x86 and ARM architectures?
I don't know the answer to that, so I would have to double check. So if there's anything that I can't answer right now, I'm going to be in the Open Source Summit, Open Security Summit Slack, and then I'm also, you can find me on Twitter. Again, DivineOps is my username everywhere, so feel free to use that. All right, so I'm going to start commit. I'm going to commit it directly to my main branch without a pull request. Usually the normal workflow would be for us to do a pull request. So I've committed this. So hopefully the demo gods love me today, and we'll see. All right, so it started the run. So again, I went to the Actions tab, and then I see that it started the run for the workflow that I just defined, because we defined a trigger to run on push, right? So any push to this repository will trigger this run. So Now you see how the matrix plays out, right? I'm actually simultaneously running all of these jobs, and I guess we're being slow today, of course, because I'm doing the live demo. All right, so we can see that some of them are beginning to complete. So while you're making your cup of tea and just, getting prepped to do other things, this job is completing. Let's see what it actually did in here. So we can see that we can get the logs for the whole thing. And that's kind of where this starts being interesting. So we got the npm CI, it added 243 packages. Wow. Then there wasn't actually anything to run here. And then it ran all the tests. So I can see the test matrix. And I can also do the go in view, like I can do show timestamps, so I can see the exact timestamps of things. And I can also do view row logs. So that will display the whole thing. So if I wanted to kind of easily browse or download this file or see in more detail what actually happened, I could do that. So basically, I just ran the entire test suite across multiple different OSs. And just if you think maybe that's not super useful, I don't know. I just had it, a test fail on Windows just a couple of days ago out of the blue without any changes to the app because one of the dependencies had some issue and needed to be upgraded. So this definitely happens. And it's definitely very, very helpful for you to make sure that your app continues to run, right? So in this case, we just said that we're going to be able to run this every time we check into this repository. And again, you don't have to do anything more. It's just going to continue running and verify that it works. All right, I'm going to stop if there's any other questions that anybody wants to ask right now.
So I missed the part where you did any changes so that you could commit and trigger it. So I made just a simple change on the README file. Is that okay, or do I need to do something?
Yeah, so absolutely any push into this repository right now is going to trigger a build. So basically it's going to trigger this workflow because we have defined. So let's go back into this. I'm going to go back. Sorry, not what I wanted to do. I'm going to go back into code. So our files actually land in .github workflows. Mm-hmm. So if I go back into workflows, I can browse through this file. It's a YAML file, and it's just like any other file in your repository, right? And so I can see that I define the push on branches. And so when you push into the main branch, it's going to trigger this. So not on commit, but on push. If you do this in the browser, it automatically pushes when you commit. So that's what happens. So we can also edit this file. So again, I'm going to pause one more time for questions. So if there's anything that people want us to ask.
It is like you are working with containers, right? Is the question.
So I'm not sure what that means because we are actually working on a VM right now.
Files, I think. Oh, YML. Is that also pronounced YAML?
Yeah, it's YAML.
Okay.
Yeah, so this is actually running on a VM. So every single job that we saw was running on a different VM. So for that matrix, right, which had 9 different things, each of them was running on a GitHub hosted runner.
Mm-hmm. Okay, the follow-up explanation to that question. So it's like working with containers when you configure the YAML files in this context.
Oh, okay. So yeah, it is YAML. It is the same YAML. So the YAML schema So I later have the links to it, but basically GitHub documentation pages have the definitions for everything that you can do with that schema. So kind of what the triggers are supposed to be and what the steps are and how do you define a matrix and things like that. So there's obviously some things that are valid and some things that are not valid for the YAML definition. So you definitely need to browse the documentation to figure out what's available. Okay, I want to keep moving. So I'm going to show one more thing for this particular thing. So we can see that we have Marketplace here that comes up immediately when we start developing the workflow. And so we can see that there's a bunch of different ones, different actions here. So I'm going to go into cache. So caching essentially caches your packages and other artifacts that you do. So for instance, in here, I downloaded 243 packages. It might have taken a second. So I don't want it to do this every single time I run the action. So I can add the caching action. So let's see what it does. So I can read the docs and figure out what it does. I'm actually going to go straight to examples into Node. Okay, and then I can see that there's different workflows, so multiple systems and whatever. I'm just going to pick the code block that is just Mac OS and Ubuntu and not the Windows one. And then I'm going to go back into editing. So I'm going to add a step here. Unhelpfully add stuff for me that I don't want. Great. All right. So I'm going to add a step here. Now, again, this is YAML, so it has to be indented exactly right. So let's see that. Man. I think that should be, nope. That's why we love YAML. Is that right now? No. Okay, fine. So this is me, a snippet on me debugging YAML. So we know that this will only run on macOS and Ubuntu. It won't work for Windows. So actually we need to add an if statement. So we can have an if logic in here and we can say runner OS. Again, you need to browse documentation to figure out what's available in here. But we can say if runner OS is not Windows, then run this caching step. And again, I could do a different step for Windows, but I'm just going to keep it here for the demo, and I'm going to do start commit. Right, so what happened here is that we just added another action. So any action that was in the marketplace that was already implemented, we can pull it into our workflow with just, you know, a couple lines of code, and then we can configure the workflow that way. And again, if you implemented your own action, obviously you can use that as well. Okay, so we just ran this. And we can see that it kicked off again. And if we go into logs, we will see that it actually also did caching. So if I ran it multiple times, on the second time after we implemented caching, it would run a little bit quicker. All right, so I'm going to go back into slides. Before I continue, if there's any questions, we can talk about them.
I'm still figuring out the indentation because mine has failed.
Okay, so what you can do is you can go into the second repo that I shared, and it has an example of the full file. So if you go into calculator action demos /CI/node CI with cache, it will have the full YAML file, which works. And then you can just copy paste the entire thing and replace the thing in your browser. Because yeah, YAML is extremely touchy. It's sensitive to any spaces or any indentation stuff. So yeah, that's a non-fun part of YAML, definitely.
And we have a question. Does it support Linux from scratch, building custom Linux distros?
I don't see why not, but I haven't tried that. So I'm going to table this question as well.
Thank you.
But I think, like, if you had a Linux repository implementing a Linux distro, you can definitely have an action that would like build that repository. All right, so I'm going to go into parts of the workflow, and we're kind of moving somewhat slow, so I might be quick about this. So if you want, you can follow these links. And again, if you just Google for GitHub Actions workflows, you can find these links pretty easily. So basically, this will allow you to, this slide overviews the triggers. So you can do different things. And again, we saw that a lot of this is about push and pull requests. So we can have this. We can also have release and other things and like specified branches that it runs on and stuff like that. We can also run on schedule, and we can also run on external triggers. So we will kind of talk about that as well. So there's different triggers, and this is how the workflow starts, right? And then what we do is we run a job. So each job defines on which machine it's going to run. And then it defines the steps that go into the machine. And then obviously we didn't have to run on a matrix. We could just specify a single OS and a single version of Node or a single version of whatever language you're using. But matrix just gives us the ability to test multiple things at the same time. And then if we get into the steps, basically what we can do with steps is two things. It's either we run predefined actions. So this is actions that someone has written, or if you have implemented an action, you can also use your own, obviously. And then you can also run shell scripts. So whatever your operating system on the runner is, you can run shell scripts on that runner. So, okay, so let's get into the second demo. And again, this is the same repository. So we've already used this. If you've already done the template, you don't need to do this again. We're just going to reuse the exact same one. Okay, so we are in the Actions tab, and we see that we have this one workflow implemented here. We can add the new workflow. So you can have multiple workflows, as many as you want. So you can run multiple things on the same repo and trigger them on different events. But here, it suggests, one of the things that it suggests to me is that I could push it into GitHub package registry. But what this workflow does is it pushes it as a node package, so like an NPM package. But this app is actually not an NPM package. It's a full app, like it's a web app that you can deploy. So what we're going to do is instead we're going to package it as a Docker container, and then we're going to push it into GitHub package registry. And GitHub package registry is, if you don't know, GitHub now allows you to host your packages on GitHub. So if I go to mine, I'm going to actually have no packages right now. But basically, I can tie packages to my repos and host different, so I can do Maven or NuGet or NPM packages. And then I can also have like entire apps in Docker containers. So this one we don't need anymore. All right, so I'm going to browse to here and try to find my Docker container, wherever it is. Man, it's going to be all the way down. Just search for it. And everything, of course, has a name Docker. All right, we're going to do set up this workflow. And again, if I knew exactly what I wanted to do, I didn't have to search for the workflow. I can just start writing a new YAML from scratch. But obviously, it's nice to have the ability to have an example that I'm working with. So this actually is going to define a trigger. And then again, these triggers are the same. Probably in the real world, what I want to do is do something like this, because I don't want to. Let's do that. And again, the indentation has to be correct. So, all right. So what I do in the real world is probably going to be just running on release when release is created, right? Because you don't want to push a new package into a new version of a package every time that you are committing to a repo. But basically, in here, I'm also leaving the pull request trigger just because we want to have the ability to demo this right now. But again, in the real world, we probably want to limit our pushes to just having the useful release steps. And then I'm going to copy paste the whole thing. So this is in the calculator actions demo repo in the GPR Docker image push. So there's a YAML file that we want to look at, and I'm going to copy paste from there because there's absolutely zero chance that I would type it all correctly, essentially. So we're taking a cheat step. So what this is actually, you will notice it's just a shell script. So all I'm doing here is running the shell script. So I didn't have a pre-implemented action to do this. I just wrote a shell script that is doing what I want it to do, right? So the first thing I'm doing here is I'm doing like hello log with an echo. So this is like going back to the, early days, like we can debug our workflows, essentially our shell scripts with the print statements, and it sometimes is useful to see what's going on. So that's kind of a nice thing that we can do that. And then we have predefined environment variables. So essentially, instead of typing my GitHub username, I can use the GitHub actor here. And then instead of typing GitHub repository name, I can use the GitHub repository. And this actually has my username and then the repository name. The problem I'm having here is that Docker wants it lowercase, and my username has uppercase letters in that. So I'm just doing too lower on this. And this is just a Linux command, right? And this, by the way, runs on Ubuntu latest. It's not running on any other system. So it's just going to run without any matrix, just one system. And then I'm doing set version. So this is just date to string. So I want to give my container image a version, and I want it to be unique. So that's just going to convert a date to string. And then this is a secret token that can basically you can authenticate with, and it's automatically created for you. So instead of having to figure out how to authenticate to different things, especially to get a package registry, which is also part of GitHub. So we want to make it as easy as possible for you. You could, normal command would be Docker login here, but this prints our secrets into logs. So I'm going to do this instead, which is a little bit complicated, but it basically doesn't print the password, the token into the logs. It's still going to complain that I should use like a token store, but we're going to do it like this for now. And then I'm going to build the actual image. So just build the repo and have app is the name of the app and the version, and then push that into Docker package github.com. So this is my URL for my package registry. I'm just going to do start commit. And I'm going to create a pull request for this one because we said our trigger was pull request. In the end, create a pull request. So again, if you missed what I was doing, you can go here. This file is in Calculator Actions Demos in the GPR folder, and you can see the entire code, and you can copy paste it into your workflow. All right, so let's go here and see if it's running. So now again, because it's a push into the repo, it's going to run both the node package, the node CI, and the Docker container push, right? So they're unrelated, but it's still both running. And then let's go into here and just go into the Docker one and see how it's doing. All right, so this might take us a second, and since we're kind of under time, because this build is a Docker container, so I'm just going to switch back to slides while it's doing that. All right. So first of all, questions on what we just talked about. I know this was a lot of information in a super short time. All right, either you lost me or, yeah, go ahead.
We do not seem to have any new questions.
All right, no worries. Either you lost me or you just all rock stars and you just implement everything and everything works. In either case, again, you can go to the same links later and just take a look and figure that out. So some tips for the workflows. First of all, go ahead.
How to integrate output into a binary repository like Artifactory?
Yeah, so there's a way to push from GitHub Actions into Artifactory or anything else. We're just using GitHub packages as an example here because it's easy for me to integrate with our own stuff. But there's different marketplace actions for publishing into common repositories.
Okay, and the Docker container into a registry, like, I think it's the same. Okay. You answered the question. Thank you.
Yeah. So again, like I said, you can host in packages, you can host multiple types of packages. So like just NPM or NuGet or something, and then Docker containers. So yes, okay. So like we said, we can run shell scripts on the runner shell. We can run multi-line scripts. So this is the only thing that defines that it's a multi-line script. So don't forget that if you're doing it. And then we can use, and again, there's, if you search for documentation, GitHub Actions environment variables, you will see all the environment variables that are available to you. So you don't have to start from scratch. You can just reuse these variables, which can be very helpful. You can also obviously define your own variables. Then the GitHub token is automatically created for you. So you can use it to authenticate across GitHub, which is, again, also very helpful when you're working with these things, that you don't have to worry about authentication as much. You can also add, so every repo comes with a secret store, so you can define your own secrets. These are essentially key value pairs. So you don't have to put your secrets. Please don't put your secrets in code, especially not in public repos. You can access it this way and store them securely in the secret store. And then you can trigger the actions on external events. So this is repository dispatch. You can call it this way. So essentially, if you, again, go to the docs, it will define that there's repos, owner, repo dispatches. And then you can basically post it from some other piece of software to trigger a workflow on your repo. Then we have, like we said, scheduled cron runs. So this is cron schedule. This, I think, is every 15 minutes, if I'm not mistaken. I should have looked at the syntax. But anyway, there's, again, read the docs. It's not super explicit, but it defines how often you want to run the action. So you can trigger on schedule instead of a specific event. And then we've got the ability to define dependencies across jobs. So like we said, jobs run in parallel unless you define the needs, in which case it will wait for the first job to complete before it starts. And we can also say, like, if it failed, then do something else, right? So we can basically verify that build succeeded before we say push that Docker container into our package registry.
There's a question.
All right, so yeah, absolutely.
Regarding the authentication, what if I'm using multi-factor authentication?
Yeah, so I think you have to essentially define a automated, like the PAT token. So you have to not do that. Like this is very common for automated workflows, that you will have to rely on a secret and not use multi-factor authentication for that particular case. Because, like, obviously we can't phone you every time an action runs, right? So again, it's very common. Most tools let you have a secret that is for automated workflows as opposed to a user who needs an MFA. So, okay, so let's see. We built a Docker image in here, and it took us a minute. And then it essentially just completed that, but it also pushed the Docker image into my packages. So hopefully that worked. Let's see. All right, so we have a single package right now in here. It's called an app. The version is a date to string. And then essentially, if I kept pushing to the packages, it just would keep defining different versions. So I could download different versions. And then this kind of gives me a way to pull this from command line. And of course, I can define different ways to pull that image. So this is essentially a public hosted package repository. So you can use it anywhere you use your packages. And again, it's free for public repos or for open source projects. So if you have projects that are open source or public and you want to have a repository for free, package repository for free, you can use the GitHub package registry. All right, so let's see. And I just have a couple more slides on here. So how you get started, one thing you can do is you can go to labgithub.com and it will teach you how to create a new action. So you can also do that. It also obviously is very helpful to just get started with these workflows. Like I said, the most common thing that we see is that people define the build for their projects to run the build and tests and make sure that every commit actually like compiles and then is able to run tests. So again, I would say before you get into implementing your actions, just start with reusing the actions that already exist. And then the marketplace has, a few thousands current results for actions. So you can browse that and figure out which are useful to you and which you could run on your repositories. And then you can go to this link to just get started with the docs. Yes, and it sounds like maybe there's questions.
Yes, there is a question. Is the dispatch event still only work for master, or can we trigger action on other branches?
I believe you can trigger on any branch that you have, but I need to go look at the docs for that.
Thank you.
Okay.
Are actions available on GitHub Enterprise?
Yeah, so it's coming shortly. Like in the next couple of months, there's going to be a beta. We are impacted like everybody else by the current events, world events. So, but hopefully in the next couple of months, you're going to see the beta for GitHub Enterprise Server. So, and again, I have to clarify this. GitHub Enterprise Cloud. So if you're hosting your GitHub Enterprise in the cloud, it's available today. So you can start using it now. If you have server, which is like your on-prem or in the cloud GitHub server private, then it's going to be available in a couple of months.
Thank you.
Okay. All right. So I'm going to give everyone a short break, including myself. And while we're on this break, please go into the CodeQL workshop. Again, it's a short link, so github.co, CodeQL workshop. I'm going to paste it again into our chat.
I've done it for you.
All right. I'm going to do it again. That's right. So unlike this one, there are actually some prerequisites for this. So if you are able to go and so if you don't have Visual Studio Code installed, then you need to install Visual Studio Code. And if you have it installed, there's a couple. So you need a CodeQL module and you need a database. So basically, go ahead and check this out now. And I think we're going to start back at the top of the hour.
Dear name, we're not going to get into that discussion.
What happened?
Why women? Why not Wim? Is asking he or she, but
what was the question?
It's a joke. Don't worry, it's okay.
All right. All right.
So 2 minutes.
Yeah. So more like let's say 7 minutes.
7 minutes. Okay.
All right. So I'm gonna make myself tea.
Cool. I stopped the music because we're live on YouTube and I have no way of pausing the recording. And it might give us some copyright errors later. We don't want that.
All right. I hadn't even thought of that.
So I need to open my VS Code. I am a little bit stuck here. Oh, we also have some questions here. Is there a Python demo?
So Python demo for what specifically?
Right.
You can't run a workflow in Python, but you can definitely use actions to build CI for Python. So if you, I believe it should come up, like if you go and you have a repository which implements Python and you go into actions and you just start, I believe that one of the things that should come up is CI for Python. So you can try that.
Thank you. Another question, is it possible to share a workflow between multiple projects?
Yeah, sure. So this is just a YAML file, right? You can like copy it or use it as a template or put it in a like different repo and get it from there. It's not, it's an interesting, I have to get back to you. I don't want to say it's not available, but like, as far as I know, it's not available to just plain use the same workflow for different files. But you can basically get the code across.
Okay, but it's a copy paste basically.
I believe so, but it's a good question, and I'm going to double check that what I'm saying is correct. Okay, is there, yeah, okay, I think that was all the questions. So we can dive into the CodeQL part, and again, I think, sorry, I want to do this. If you haven't done so and you intend to follow the CodeQL part and actually try to implement some queries, then please go to that link and do the prerequisites. Otherwise, you can just watch and follow. You don't have to actually do all these things. So we're going to talk about securing your code with CodeQL. So I'm just going to set up at this stage a little bit, and I know this is a security audience, but like let's just talk for a second about the state of security today. So what we know is that 53% of breaches are caused by weaknesses in applications. And actually most of the rest of them are caused by weaknesses in configuration. So basically, what happens is the code we write is primarily the cause of security breaches. And also, worse than that, what we know is that the more code we have, the more problems we actually introduce. So the correlation between lines of code and introduction of security vulnerabilities is super, super high, and it's not getting any better. So if you're a developer, it's essentially, this is the life that we live. And then like lots of developers are always like, okay, well, this is a security problem, right? So I don't have to worry about that. Well, and the problem is that we have vastly more developers than security researchers. So we have like around 40 million estimated developers in the world and only 70,000 estimated security researchers. So we couldn't put a security researcher on every single repository and have them monitor every single code push that a developer does. So what we also know in addition to that is that if a breach happens, it can cost you millions of dollars. It's actually quite scary. Like the breach remediation is not something that you want to be a part of. But the farther left we go, the cheaper it gets to remediate a security vulnerability. If you're remediated during development, it's actually quite easy to do, right? So we want to shift security left, but we haven't really figured out as an industry how to do that. And of course, we say that the answer to that is probably automated scanning. So making sure that your code doesn't have vulnerabilities when you push it. But the problem is it's not actually really happening. So only about 5% of applications are scanned weekly, and less than 1% are scanned daily. And that's just of applications that are actually using static code analysis. So what we see is like there's not a lot of applications that actually use static code analysis tools. And of these, like probably none of them or almost none of them are scanned on every commit. And it's just a miss, right? That means that we push code constantly and we constantly introduce potential vulnerabilities. And we aren't actually helping solve this problem. And so GitHub has a solution for this, which we hope can help secure more applications, and especially things that are public repos and open source. We're aiming, like everything we do, we're aiming to make it free for open source and public repos. And so we want to bring the code scanning to the developers and shift it left so we can identify security vulnerabilities as early in the process as possible. And so I'm going to be talking about two things today. It's code scanning and CodeQL. I'm just going to mention code scanning because it might be relevant to you in the near future. And then we're going to dive into CodeQL. So CodeQL is essentially a query-based semantic code engine. It was developed by a team at Oxford University. It took them a lot of research to be able to implement the language. Essentially what it does is it treats your code as data, right? And in that is, then it scans it with queries, and these queries can be customized and can be implemented by you. So again, everything we do aims to be community-based and open source. And so it's not just that we implement security queries for CodeQL, anyone can, right? So we're gonna talk more today about how we can do that. And then we can, again, we have a security team that drives the database of these queries. But then again, anyone in the world can contribute. So what's code scanning? So code scanning is essentially CodeQL and other partner side code analysis tools as a service. So what we notice is, so to do CodeQL, you actually need to configure a server, right? And then you need to, in like most SaaS tools, right? You need to set things up to be able to run it on your repos. We wanted to make it as easy as possible. So actually what we're doing with code scanning is we are using actions to allow people to run CodeQL analysis on GitHub hosted runners. So kind of like make the best of both worlds. And so this feature is right now in beta. So you have to sign up for this. You won't be able to, so I'm going to show you a demo of this, but you won't be able to do the same thing because you need to first enroll in beta. But once you are approved for beta, you're going to be able to just run the CodeQL on any repo, any public repo that you have. And so you can find vulnerabilities before they're merged into code. And then you can run custom queries and community-powered GitHub query set. And then the code scanning also actually supports other tools, so we can have partners in there. So it's not just CodeQL, but other potential security tools. So let me just show you code scanning and talk about this. So essentially what we want is to create an automated code review. So when you check in and you submit a PR, we're running automated code scanning, identifying vulnerabilities. And then on every commit subsequent to that PR, and then you can also run on schedule. So essentially, again, we're using actions to run CodeQL on every public repo. Again, that's an aspiration. It's right now in beta, but we're getting there. So let me show you this. And you can also go and sign up for the code scanning beta because, like I said, you won't be able to follow this one, but I'm going to show it to you. So let's go. Man, great. I have to avoid the Zoom thing. So let me go into my repos here. I should have actually opened it while we were on a break.
There is a question.
Sure.
CodeQL integrate the SaaS partner tools, or do you need CodeQL to integrate SaaS testing into GitHub?
So CodeQL is a semantic code analysis language. Code scanning is a tool using CodeQL, but code scanning can also use other tools. I think it's going to be clearer when I go configure this. Well, so maybe we'll get into the demo. Yes, it is SAML. It came from a SAML acquisition. So I have, again, everything in here is JavaScript today. So I have a really simple JavaScript repository. There's nothing really in here. And And what I want to do is configure code scanning on it. So I'm going to go into security, and then I'm going to have this setup code scanning. And if you don't have access to code scanning yet, which you probably don't because it just came out, you are going to also have an ability to sign up for the beta here. So I'm going to do setup code scanning. And this is what I mean. So our code scanning options are CodeQL analysis, and then we have a couple partners right now. We're adding more partners as we speak. So to set up code scanning, you can set up with different tools, but today we're talking about CodeQL specifically. Go ahead.
I'm confused. So I'm familiar with SEML. What I don't understand is if I want to integrate, I know there are some new partner tools out there in the SaaS space. Do I need to have CodeQL enabled to integrate the SaaS tool? Is it chained that way, or is it separate? That's what
no, so this is just an action to run your static code analysis tool, right? And depending on which tool you run, the action is going to be different. This is not, it's not tied into CodeQL. So if you're using Rubocop, it's not going to use CodeQL. So I'm going to do this, and this is going to create an action for me. So notice this is the same kind of workflow that we did before, and it's just creating an action. And here we talked about it, like we ideally wanted to run on pushes, on pull requests, and then on schedule, because in case something new came out that we didn't know about on a push, right? And then it's going to do a CodeQL build. In this case, it runs on Ubuntu latest. It checks out the repository, and it checks out its parents. Really, you don't need to make any changes here. For most repositories, if you just commit this action, it's going to work for you. Now, the one thing I want to mention here is that for compiled languages, you might have a complicated build process. And if you do, then you need to configure the steps here. For most projects, the auto build is just going to work. So we're going to try to build your solution or your project or whatever it is, depending on the language, and it should work. And again, for interpreted languages, that's not an issue at all. But if you have some type of complicated build steps, you might need to modify this. I am not going to modify anything. I'm just going to commit this as is. So I'm committing this file. Now, because it takes a moment to like kind of configure this all, I actually have a repo on which I already have this configured. So I'm going to go back into this, and I'm going to go into my script.js file. So we're going to now create a pull request. So in here, I only have like a super simple script file. I also have some secrets, but that's a thing for a different day because we also scan for secrets. So GitHub also helps you catch these things and identify that there were potential secrets. But I also have a function. So it's just a simple function. It checks if if the string at y ends with x, right? So I'm going to make a simple change to the function. So I'm just going to optimize it. I used to, in high school, I had a CS teacher who said that every function can be shortened by one line of code. So we're going to do that because we're super optimizing today. And then we're also going to do something else because I want to show you one potential security vulnerability, which is SQL injection. So in here, I'm actually committing code that is vulnerable for SQL injection. So I am defining this database, and I'm also defining an app. And I'm actually going into here, and I'm just straight up getting the parameter from the request, from the web request, and adding it to my SQL query. And so we know that this code is vulnerable and that it's going to be a problem for us potentially. Now, I'm going to create a pull request off of this and propose changes and create a pull request. Now, again, this is going to kick off our checks, and this will be a CodeQL check. So we don't have to wait for this. I have one that already ran, and we can see that CodeQL actually complains that there's some errors on there. So again, I pushed new code. It automatically triggered a CodeQL scan. So I'm going to go into details on here, and I'm going to see that there's actually 3 errors. So I just committed like 10 lines of code, and I have 3 errors on there. And I would never know if I didn't run this code scan, right? So what I'm seeing is that, first of all, my optimized function is actually not that optimized. So let's see, show more details. So it says incorrect suffix check, and then using index if is error prone in case -1 is not explicitly handled. So in this case, it will return true if this actually happened to be -1, regardless of whether Y contains X or not. So it just caught a bug for me. And like, I wouldn't know that this bug existed. And I can also review more details and see what vulnerabilities it might be related to and things like that. Now, more interestingly, it also caught our SQL injection thing. So it says, okay, the query depends on user provided value. So let's go in here and see our details. So it says, okay, query 1, you have user provided value in here, and then it specifies that I built it from user provided data without sufficient sanitations, and explains this to me. Again, more links to more documentation and the good examples. So something that could change it to sanitize the query. Now, one of the cool things about this is that this is only caught if this is getting used. So if I just had this construction, but I didn't use it anywhere, then it would not actually red flag it. It's only red flagging it because I'm actually using it and getting user input and actually getting it into my query. So we saw that in just a couple of minutes, we were able to configure code scan with CodeQL. And we are going to be able to scan our repos for things like that. It actually caught a third thing, which is I'm using database access, but I'm not rate limiting it. So in the existing CodeQL queries database, there's lots of queries that you can use. And these queries were defined by either the community or our security researchers. And these queries catch lots of common vulnerabilities. So that's just a snippet on the code scanning, and I'm going to pause for questions. And if there's no questions, that's fine. Now, if you want to follow the second part, again, the prerequisites are here. We want to be able to define these queries, which requires us to install a couple of things on our local machines. So if you haven't done so, you can do this right now. Now, let's talk about, go ahead.
Was the scan conducted on the code delta only, or was it the entire project that was scanned?
Yeah, so it's in the entire project. It takes the entire project that, it takes like a snapshot of your code at that particular moment, and it conducts a scan on the entire thing. And if you're using a compiled language, it actually also does a build. So it like makes sure, because in compiled languages, it depends on like compiler flags and things like that, what actual execution is going to look like. So it takes into account a successful build as well.
Thank you. And Avid, you raised a hand, but now do you still have a question? No.
Avid's all good. All right, that's fine. So let's just proceed to talk about the language. So what is CodeQL actually? And again, we just ran code scanning with CodeQL, which was just leveraging actions to run it in the cloud, but it's actually a language that we can contribute queries to and use queries that are already there available to us. So that's a new language. So why would we define a new language, right? There's a lot of languages out there already. So it has quite different features from the things that we know. So first of all, if you're familiar with query languages, like it will look similar to SQL. So there's like the syntax is going to be similar if you've used SQL queries before, but the language is logical. It is declarative, so there's no side effects. There's no if-else statements. There's just declarative statements, which are going to execute the same regardless of the conditions. The language is object-oriented, so we have concepts of classes and concepts of inheritance. So we're going to see some examples of that. It's going to become clearer why it is useful. The language is read-only. I know it's strange to say that about a language, but it is actually read-only. So you kind of start with a group of definitions that you already have, and then you identify conditions on these definitions. You can't actually create new things in the language. And also the database that you're importing, which is your code, is read-only. So once you take a snapshot of your code, it becomes read-only, and you're only running scans on that particular instance. And then it's equipped with rich standard libraries, which is the power of the language, right? If we didn't have any standard libraries, then you would have to write everything from scratch, which would take you a long time and be inefficient. But since we already have rich standard libraries, a lot of things become easier to implement, and you don't have to write everything from scratch. So the supported languages right now are Java, JavaScript and TypeScript, C#, Python, C, C++, and Go. I don't believe we have anything else coming out shortly. So if you have a favorite language, reach out to us and we will see how we can get it in the pipeline. But these are the languages available right now that you can use CodeQL with. And like I said, by the way, like if it's a little bit different for compiled versus non-compiled languages, but it works for both of them. So let's talk about what a query actually looks like. So a query is basically a statement that starts with something like import the language library. So it's import JavaScript or import Java or whatever language you're actually using. And then there's from, where, and select, right? So again, if you're familiar with SQL syntax, it looks kind of similar to that. And then there's logical operators and or and such that you can use there. So you start with declaring. Go ahead.
Hypothetically, can I build my own support for another or custom language? How complicated would that be? Is one question.
Okay, would be quite complicated actually.
Okay, and the second is what languages are on the current roadmap for CodeQL?
So as far as I know, that's the set that we have, and like not in an immediate fashion, we don't have anything else that's going to come up.
Okay, thank you.
So, all right, and then again, these were the languages. So hopefully your favorite language is in here. Okay, so we start with importing the library, and then we continue with from. So the from statement actually has variable declarations, right? So we have a variable declaration and then the name of the variable. So basically we can list multiple variables in here. And so what this refers to is all the if statements in code. Right. So when we declare a variable, remember the language is read-only. We have a language library which knows what an if statement looks like. And so when I start from here, that means I just got so the from statement got all of the if statements from my code, which is my database, right? And then this got all of the blocks. So typically curly braces. So this got all of the blocks from the code, right? And then after I did that, I can define conditions that limit the statements that satisfy the condition. And then I return it. So I return one or more things. And in this case, I return all the if statements that are satisfying the conditions. So let's talk about the conditions really quickly. So block equals if statement get then, right? So what this means, and you could probably read it logically, right? Even if you don't know the language, you can see that I took all the block statements and then I said, I took all the if statements get then. So it's a then statement of an if statement. And I said, this is now in a variable called block, right? And then I also said, and, so another condition, and block dot get num statements. And again, this is implemented in the language libraries. That block has a predicate that says get number of statements, right? And then I say if it equals 0. This is not an assignment, and equal sign is always a comparison. So in this case, I'm always asserting that get number of statements equals 0. So essentially what we just defined here is that we're getting a get then statement, which has no statements inside of it, right? So this is an if statement that has an empty then block. right? And so if we run this query on our code, then it's going to return all the places in code that have this syntax. Questions? I just need to pause honestly.
No news.
All right, it's okay. So let's talk about the building blocks of a query. So we have predicates. Predicates are essentially functions that take arguments and return true or false, right? So it's a logical statement, and we can define this logic and give it a name. So we could run the same statement as just lines of code in here, or we can define it with a predicate, which allows us to give it a name and then reuse it, right? So in this case, I'm defining a predicate which says is empty, and it takes block as a parameter, and then it will say block.get number of statements equals 0. So it will return to me all the blocks in which number of statements is 0. And then I can run this in my actual query, right? So my actual query looks similar to the former, but instead of doing the 2 lines of code, I'm just asserting is empty. So I'm asserting that the predicate returns true on the if statement .get then. So essentially the 2 things left and right will return the same results. One I'm using a predicate, the other I'm not. Then we also have classes. Classes describe sets of values. And classes are always defined through inheritance. So again, we said the language was read-only, so I can't create a new class from scratch and define the types of things that it describes. This class comes from a language library, and I can extend it. So from the standard language library, I got a class called block, right? And now I'm extending it to a class called empty block. And then this empty block is defined by, and it kind of looks like a constructor, but this is basically a statement about which blocks satisfy the empty block, right? And then I'm saying this get number of statements equals 0. So essentially, I can then run this class inside my query, and then I'm going to say if statement get then is an instance of empty block. So again, the logic of this is the same as the previous one with the lines of code, and the same as the previous one with the predicate, but I ran it with a class. And classes can be useful because classes can define different predicates already. So like we saw this before, that I could run block.get number of statements and it returns something to me, right? Because it's a predicate that already exists in the language. So essentially, I can also define my own classes and then run the predicates on them. Okay, so let's just go and work on a particular vulnerability that we want to identify. So I'm going to run through workshop content for the next, and so we don't have all that much time, so we're going to run through as much of the workshop content as possible, but you can then also continue running on your own. There's also a recording of the workshop, so you can also see a nice coworker of mine presenting the whole thing. So you can basically do that. And also there's a similar workshop for Java, so you can also do that if you prefer Java to JavaScript. And again, we have content for other languages as well. So what I'm going to talk about here is identifying cross-site scripting in jQuery. So jQuery is kind of an older library for JavaScript, and I say older, I don't know, I think it's about 10 years old, which is old in web years. But the thing is, like, lots of web still runs on jQuery. And the problem with jQuery is that it's particularly vulnerable to cross-site scripting, because a lot of times we take DOM elements in jQuery and then we just execute them. And then this can backfire because someone can, in this case, the text selector was supposed to be just a CSS element, but a malicious attacker could just inject a JavaScript code in there, and then they would get to just execute it. In particular, the situation happens a lot with what's called jQuery plugins, which extend jQuery object. And the biggest issue with cross-site scripting is actually that it could be like thousands of lines of code before the thing is actually executed. So it would be easy if I just got something from a user and then I immediately executed it. But it might be buried throughout my flow in my code. And it might be very, very difficult to find that it's actually coming from a user input and then getting executed. So we're going to try to build a query here that is going to be able to find this. All right. Again, if you didn't do this before, you can go here. It's going to be useful to us, not just for the prerequisites, but also to follow the flow. Okay. So with this, I'm going to go into my Visual Studio Code, and this is zoomed in probably as much as I can, so hopefully you can see the code. But so if you did the prerequisites, it downloaded a workspace which already has the standard language libraries, and in particular, it has the standard language libraries for JavaScript. So I'm also going to start and create a new query here. I'm just going to name it my query.ql. And this is going to be what we're working with. The other thing that I want to show you is that we have a database in here. So this database, again, if you follow the prerequisites, it had a link to where you can download the database from. The database is actually code. It's one of the earlier versions of implementations of Bootstrap, which actually, I believe the CodeQL team actually helped Bootstrap find a number of vulnerabilities in their implementation and fix it. So this is just one of the earlier versions in which they actually were vulnerable to cross-site scripting. All right, so we can close this right now. And then let's look at the workshop content. So this is the same workshop content that you see in that repo. So it essentially asks us to build out the query to identify cross-site scripting in very piecemeal steps. So we're just going to go step by step and try to build the query. So the first thing that we want to do in any query that we write is to do import the language that we're working with. And this has to be in the library, in the place in your code workspace where you have the JavaScript queries already defined. Otherwise, it will have a problem. Hopefully, we don't have a problem right now. Okay. So the problem is just that I have no query, so that's fine. But if you see that it's not finding JavaScript, you're probably in the wrong place in code, and you probably want to be in the right place in code, just so the JavaScript libraries are accessible to you. So let's look at the first thing that it's asking us to do. So it says, finding calls to jQuery $function. So we want to scan our Bootstrap code and find all the places where a $function is called. Now, let's say we're all new to this language, so we don't actually know how to get started. So let's see, look at the hint. Okay, so we can say that we can see that in CodeQL JavaScript library, there's actually a definition of function call, and it's called a call expression. So we can start here. Let's do from call expression, and then call it whatever we want. And then just do select function. Okay, so this, and let's look at the solution, see that we actually did it right. All right, that seems to be okay. So I will run this. So you can run this, right click, run query. I'm going to run this on my database, and it's going to take a couple of minutes. So while it's doing that, first of all, you can catch up and try to do it on your own. So hopefully you're doing this in Visual Studio and trying this out. And then, again, I've named it something different than it was named in that other query, but I can name it the variable anything I want. The point is it's of type call expression, and then it selects everything, right? So I'm not limiting the results. I'm just selecting every single function. So these are my code results. There's lots of calls to functions. And then I can actually see them in code and browse to them. All right, so that seemed to have been pretty easy. So we just found all functions. This is cool, but now we want to make it a little bit more interesting. So let's do identify the expression that is used as the first argument for each call such as alert first argument. All right, so again, let's just browse through the hint because we might not be familiar with everything that's going on and potential things that exist in CodeQL. So it kind of suggests that we can have more than one variable in the from clause, and then that we can also add the where clause in which we will limit our the selected expressions that we have. So I'm going to give you like 1/2 a minute to think about this if you want to try to figure out what it would look like. Meantime, if anyone has questions.
Yeah, just a quick question. How do I get to the myquery.ql? And like, I've never used Visual Studio Code before. I've used other things.
Oh, sorry. So basically, if you are in Visual Studio Code and you have downloaded the checked out the workspace, there's going to be lots of libraries, and one of the libraries is the JavaScript standard, where the JavaScript standard library is defined. And there's the section called CodeQL Custom Queries JavaScript. There's going to be like an example query in there, and there's going to be a couple of definition files which just define which language it's working with. So for the query to work, you need to be in this directory, and you should have this directory if you checked out the repo. And then you define your own file, so you can name it whatever you want. And then just you can go into File Explorer and have that file here.
Okay, perfect. Thank you.
Absolutely. I'm just kind of working. It's super zoomed in, so it's super awkward. I'm just working with this. Okay, so hopefully you've tried some things and maybe just even succeeded. But basically, here's the solution for us. So we can define, as you remember, we can define more than one variable in here, and I'm going to call it the same thing as they did. And then, so what happens in here, I'm going to keep it lowercase. So what happens in here is actually I got the function calls, and then I got the arguments for the function calls, right, in the separate variable. And then I'm going to define a where clause. So the where clause is that my argument is the first argument of $call. And again, I called it something else, so I'm going to do this here. So if you didn't know that this existed, what you could do is you can just dot, and then you will see all the predicates that are defined on this type of variable. And then you can browse into that. And so this gets an argument, and we can see that I can say which particular argument I got. And then I can see a little more documentation on here. So gets an argument I of this invocation. So we should get, and I'm going to run this query. So if we run this query, we should get all the calls, all the function calls which have argument in. So I'm actually returning something else than they did, but it doesn't really matter right now. So I actually return functions, and the query in here, I know I'm switching too quickly, sorry about that. The call in here actually returned the argument. So, man, that was not what I expected. Let's try this again. No, okay. All right, it doesn't like me copy pasting apparently, so we're gonna write it. Okay, so basically I'm returning all the first arguments to calls to function, right? And I just wrote it in like a few seconds. So let's make it a little bit more interesting. We said we wanted the $calls, not just any function, but the $calls where jQuery function is executed. So I actually want to find a function that's named $. So I'm going to suspect that I can do this with another predicate, right? Kind of how we had a predicate here. There's probably a predicate that will allow me to do that. So call expression actually has a predicate that's called get callee name. Okay, and that allows you to find and the name of the function being called. And then we're reminded that we can use logic operators, so we can use and, or, and such. And then that the equals operator asserts that the values are equal. So it's not an assignment, but it actually is an assertion of equal values. So I'm going to give you like 30 seconds to think about this and try to define this query yourself. In the meantime, again, if there's questions, you can feel free to ask. Right, so hopefully you have started typing something that looks something approximately like this. So again, we said we can use an and, right? And we can define another condition. Okay, and then in the hint, we said we had a get callee, and remember we wanted to choose all the functions where the name of the function was $. So again, I'm naming the variable something else. So again, it's going to look slightly different here. But I can start, and again, if I didn't know that this existed, I can see that there's a name function. So this is my get callee name, and that will get the name of the function or method being invoked. And then I actually need to assert that it's equal to something. So in this case, I want it to be equal to $. All right, so let's see. And it could actually return both of the things if I wanted. So let's run this. All right, so let's view results. So it returned the function and the $arg, right? And then you can see kind of from here already that the function was indeed the $call, and it indeed has an argument. So basically, I've returned all the functions which have argument 0 and their first argument, all the functions that are $call calls, right? So in just a few minutes, we were able to write this query, which is able to traverse the entire Bootstrap code implementation database and return 737 results of all the functions pretty quickly. So we can look at all the things that we want to look at. Okay. Now, the fourth thing for this is that jQuery, actually, the $function is just another way to spell jQuery. So it can also be called as jQuery. So instead of $, we can use jQuery to do the same thing. So we actually want to find both of them. So now we could start saying that it's equals this, equals that. It might get kind of complicated. But here we get a hint that CodeQL standard library actually has a predicate called jQuery, and jQuery will actually return all the references to jQuery functions, whether it's $ or not. So we can actually simplify what we're doing. Instead of doing the equals $, we can use the jQuery. So I'm going to just skip over to the solution in here. So there's two options how we can get to do this. We can either do this with an expression or the data flow node. So data flow node is just a different type of reference. So expression is still valid for $arg, but it's also like, that's what it does. It always links me to the doc. So, but it also can be done with the, with the flow node. So basically I can switch it over here, and then instead of this, I can say something simpler, right? So I can say jQuery, and then get a call. Then it has so I got all the calls to jQuery here. And then again, I can keep typing. So there's an argument function. So get argument at 0. And then we notice that it's a different assignment. So it's incompatible with node. So it actually returns dataflow node. So we can either convert it to expression, or we can change the data flow here, the type here to dataflow node. I think I might have confused folks. Okay, and we're actually not using this, so it lets me know that I'm not using the function. Okay, so it kind of made it actually a little bit simpler because we used the existing jQuery library predicate, and we were able to just leverage this. So I just run it and see that it actually works. Now, I might have confused folks. I hope you're still able to follow this, so let me know if you have any questions.
Any questions?
Okay, so let's do view results. So in this case, we can see that it's the same results. So there was nothing defined in a different spelling, but it actually returned the same things. And we can see that indeed this was a call to the dollar. So now I'm returning the argument in particular, but you can see that these were indeed the functions calling dollar function with an argument. So we've just written a query that can find dollar function with an argument, which is kind of the first part of the workflow that we want. So basically, we want to find cross-site scripting in jQuery, right? So the first step is we want to find any time that the code is executed, right? So potentially any call to the dollar function, which has an argument, could be a sync for cross-site scripting. But we also need to find the source for cross-site scripting, right? Because it also needs to come from somewhere and be able to get into the sync that way, right? So we are now going to work on the second part of this query. Now, each file can only have one query. So here I'm just going to comment out the thing that we wrote already to continue working on the second part. And then in the end, actually, I'm just going to show you how to combine them together because we're going to run out of time before we get there. But we're going to do a couple more steps out of the workshop. And like I said, you can continue working with this workshop. And I'm also going to give you a link to where the whole session is recorded so you can continue on your own time and also view the recording. So in this step, we want to find all jQuery plugins. So jQuery plugin is a function that extends jQuery and implements functionality. And we want to find all jQuery plugins which have options. So basically, we want to, so again, if you just have a jQuery plugin which doesn't take input, it's not that interesting. We want to find points where it comes from the user and then gets into an argument to a function. All right, so if you have already seen how to reference jQuery dollar function, now find all places in the code that read the property of $fn. So $fn is a definition of jQuery plugin. Again, this is language specific, so we know that in jQuery to define a plugin, we need to have a reference like this. So let's see what a hint can give us. So there's a declare a new variable of type data flow node to hold the results. Notice that jQuery returns a value of type data flow source node. Source node are places in the program that introduce a new value from which the flow of data may be tracked. And source node has a predicate named get a property read string, which finds all reads of a particular property on the same object. So all reads of the .fn, for instance, can be all reads of that property. So I'm actually going to go right into the solution because we don't have all that much time left. So we are going to go and define a new variable. And again, we saw data flow node just now. Typing is hard. We're just going to call it an. And then we have the where close, which defines our conditions on that type of variable. So again, we saw this before. The jQuery function is all calls to jQuery. And then we want to find where $.fn is called. So we're going to do get a property read. And this is going to have an argument, which is the name of which property is actually being read. Okay. And then we're going to select all the nodes that look like that. So I'm going to run this query. And hopefully you're still able to follow along. All right, so let's see what it returned to us. So we can see that this indeed returned all the assignments to $FN. So these are all the plugins that are implemented in here in Bootstrap code. All right, that looks promising. Now let's go into the second part of this. So find functions where that are assigned to a property of $FN. So we just found all the $FN. We just also want to find places where $FN is actually assigned. Now remember that this is not necessarily as easy as it seems, because we actually have places where it can look like this, right? So the assignment to the function is separate from the $FN call. So we actually need to know something about the flow of the program to be able to identify this. All right, but let's see if our library can help us with that. So what we learned from the hint is that the source node has a predicate called getPropertySource, which finds the source node whose value is stored in the property of this node. So we can use that predicate to identify source nodes. And then in the previous step, we used the property read to identify $FN. Now we want to see where there's another value stored in the property. And again, I'm going to go straight to the solution on this one. So basically, we just added just a little bit of logic in here to get a property source. All right, in the end, yeah, I believe this is correct. So let's run this and see if it works. All right, so notice that I'm returning the plugin here. And again, this is the same syntax that we talked about, right? This $FN is not immediately assigned to something, but this function actually exists in here. And this is what I actually return, right? So I return the place where this actually is implemented and then it is assigned to $FN. So this is kind of a more complicated flow logic than you would be able to do if you were just writing like if-else statements and trying to find it in a very simplistic way. Now, because we don't have a lot of time, again, you can go through the steps in the workshop that built this kind of step by step, but I'm just going to skip over to the query that already has kind of all of the things. In the end, I'm actually going to run it because it's going to take a minute. All right, so while this is going to run, let's see if we can walk through it. So this is almost production ready query, and you notice it's not that long. It's not that complicated. This is almost a production ready query that was used to actually identify vulnerabilities in Bootstrap. So we can start first with our actual query. So the actual query takes a class that we define earlier, and then it takes a path node called source and then a path node called sink. So we kind of want to find all the places where data comes from the user from the source and then gets into the sink where it gets executed, right? And then I'm just calling a predicate on this class, which is called hasFlowPath. And this is something implemented in the standard library. So it's going to be able to identify that there's a flow path from the source in the code to the sink. And then I'm returning this. You will notice that I'm returning multiple things, and we're going to show how that looks in 1 second. So basically, where did this come from? So I'm taking the library for JavaScript. I'm also taking the library for data flow path graph, which implements kind of logic for identifying all the places in code where there is a flow path between one node to another. Okay, and then I'm taking a class from that library. It's actually from taint tracking configuration. Taint tracking is a library which identifies all the places in your code where you might have taint propagation. So essentially, there is data that is coming from the user that might be taint, and then there's maybe some modifications on that data, but it's not like changing the tainted nature, right? So if I concatenated 2 strings, one of them could still have come from a user and could still contain malicious code. So this kind of things like that. So I took the class that exists in that standard library and I extended it. And then I just gave it a name here. And then I define so the class has 2 predicates, like it has more predicates, but in particular, it has a predicate called source and it has a predicate called sink. And then I'm defining what exactly my source and sink look like. So I actually just got into, and I got the same queries that we just defined, right? So this source is going to find all the functions that are assigned to a property of $fn. So all the plugins. So again, jQuery, get property read fn, get property source. Again, the same, this was the second part of the workshop. We defined this query. And then it also, this is something we didn't get to, but it gets the last parameter of that. So the last parameter is the parameter which is coming into the code from the user. And then the sink is where this code actually gets executed, right? So I am getting a call to a function and getting the argument 0, and this actually is a place where this code executes. So like we said about SQL injection, if the code is not actually executed, we wouldn't find that, right? So it wouldn't pollute us with lots of false positives about like, oh, there's a call to a function here, which might be tainted. It only does that if there's actually a flow path in the code between the source and the sink, and it uses kind of complicated language, complicated logic behind the scenes to implement these libraries, which allow you to actually identify that the class exists. And again, it depends on what kind of language you use. It can have multiple different implementations for how that path is identified. And you can see that I found just 5 results in here. And if I go into here, I will see that there's a code being executed on here. In the $function, but also in addition to that, you saw that I had defined kind of a different type of path. In here, I'm using all these different places in code. So this actually went through 10 different instances from the time that the options came from the user to the time that the options actually got executed in this particular snippet of code. So it executed a very complicated path through the code to identify that this piece of code is actually vulnerable for cross-site scripting. All right, we're super almost at time, so I'm just going to switch back into slides super quickly.
We have one question.
Yeah, absolutely.
Can CodeQL only be used on public repos?
So you can use it on private repos, obviously. If you use code scanning, how about this? So you can use it on private repos as part of GitHub Advanced Security if you're using, in particular, code scanning. If you're using your own server for CodeQL, you can use it on any repo that you want. And code scanning that will run on GitHub runners will be available for free for public repos. But again, you can run it on any repo that you want. And if you just like run it by yourself without the help of code scanning, again, you can define it on anything. And it doesn't even have to be a GitHub repo if you wanted to run it on something else. All right, so I'm just gonna wrap it up so we can finish on time. So we identify like lots of CVEs. So you can see that SAML and now CodeQL has identified more CVEs lately in the last couple of years than any other tool that we're familiar with for static code analysis. And we can also see that this is my favorite number. 72% of vulnerability identified with CodeQL are actually fixed. So this is kind of our guess at how many of them are false positives. So we think that there's not a lot of false positives just because we see the very high rate of people actually fixing them. And then again, we have lots of open source queries and lots of public repos that already do review with CodeQL. That was before the code scanning was released. So they were just running their own CodeQL instances. And then 18% of recent JavaScript CVEs were actually identified by CodeQL query. So these are pretty awesome numbers. I think we have kind of groundbreaking engine here compared to the other things in existence. So hopefully it helps folks do security analysis. We have lots of resources, so I'm happy to copy paste it into chat and give it to everyone. We have different CTFs also that are running, so you can try to do the same things we did as a workshop. You can try to do them as CTF. Currently, I believe Java CTF is still running. You can also get into past CTFs if you don't care about the points. So there's JavaScript and I think C and C++. And then there's free courses, there's different libraries. And then if you get very familiar with the language and you want to contribute your own query, there's also a description on how to contribute your own queries. And like I said, you can leverage the queries that already exist. And if you're running CodeQL, you will be leveraging the queries that we already have. But you can also define your own queries and you can share with the community, or you can keep it just for your code base and keep it private. So you have the ability to identify things that are very specific to your code and might not be interesting to other folks. All right, so thank you. And let me just copy paste all the links so everybody has them.
Woof.
Yeah, that was a lot of information. I know. I'm sorry it goes so quickly. But again, feel free. So the workshops are definitely so Java and JavaScript are the ones we recently recorded. So you can definitely go watch that. And then there's some other resources for other languages.
And
right.
Do we have any further questions from the audience? We got some really good feedback both in this chat and the YouTube chat.
Thank you. I'm happy that it's helpful.
I think my next time going through it will definitely be what it takes.
Yeah, I think for everything like this, you need to kind of make a couple of passes. And this is a totally new language we're talking about, and lots of dives into documentation to understand what is available to you and what you can leverage. Yeah, definitely.
Vinod, do you want to unmute? Vinod?
Sorry, it was a mistake.
All right.
All right.
And like I said, feel free to reach out to me. If you do sign up for beta, you can try to reach out to me on Twitter. I can try to make sure that you're whitelisted for code scanning beta. And other than that, again, all the links are public, lots of public learning resources for this.
That is a good question in the chat. He says, are you using all 1,700 open source queries for the public GitHub?
Meaning, so like, do we run it on all of our repos? So if you configure stuff to run on your repos, obviously it's going to run. And if you're running CodeQL analysis, then yes, you're going to be leveraging all the queries available for your language that are in the standard query library.
Does that answer your question?
We don't run it on your repo if you didn't configure it, obviously.
I don't know if that was the question.
Yeah, that answers my question. Thank you.
Okay.
Perfect.
Right. Cool. Thank you all so much.
I have one more question. Do you publish the metrics for each query in terms of false positive rates?
Yeah, so this is not that easy to identify, right? So for each query, like if you run it, you have a choice of whether to fix it or ignore it. So you can, basically what we do is see how many people ignored it. And I believe the options are also to say that it's false positive. it's a good question whether or not we internally track that it's false positive. I'd have to go back to you on that. I do know that we track how many people ignored it versus how many people fixed it.
Are there any metrics out there that one could use to limit the amount of queries that they want to run for an enterprise?
I should know the answer to that, but I don't. But I believe you can. You should be able to select the queries that you want to run.
Okay, thank you.
But this is an excellent question. I should get back to you on that.
Thanks.
Another question. Did OWASP SAST benchmark run to get the CodeQL metrics?
Yeah, I don't know the answer to that either.
Okay.
These are all excellent questions. I'm sorry, folks. Always. All right, there we go.
Thank you so much. I will now stop the live stream.